Hello everyone. Today's topic is conditional probability. Now, before we start with conditional probability, I would like you to recall if A and B are two events, then probability that A or B or both happen is probability of A plus probability of B minus probability of A and B or A intersection B. When A and B are independent events, then probability of occurrence of A and B simultaneously or one after another is considered same. Hence, we have probability of A and B or A intersection B is PA times PB. If A and B are dependent events, means the occurrence of first event affects the occurrence of second event. In that case, what will be the probability of A and B? If A occurs first, the probability of B depends upon event A. And how do we express this? We write it as probability of B after the occurrence of event A, we write as PB slash A. So B, this is basically probability of B. This slash A shows that B depends upon A. Similarly, if B occurs first, then the probability of A will depend upon event A. So how do we write probability of B? This will become B slash. If B occurs first, then what will be the probability of A? It will be A slash B. So basically it is probability of A and slash B shows that B has occurred first and A depends upon B, right? So these two are probabilities under some conditions. So these probabilities are called conditional probabilities. Now, today we will learn how to find conditional probability, and when it looks in the question, if you get a question on conditional probability, how to identify whether it is a question of conditional probability, right? So let's continue. So going back to conditional probability, in simple term, we can say conditional probability is the likelihood of an event occurring given that another event has already happened. So here the most important thing is to identify that there are two events out of which one has already happened. Now, when one has already happened, you need to update your sample space on the basis of which event has already happened. So it allows us to update the probability of an outcome based on new information or specific constraints. New information means we'll be given that some event has already happened. According to that, we will adjust the sample space. Have a look at this example. A fair coin is tossed twice. Find the probability of obtaining. So we will discuss this experiment in two different ways. Number one, find the probability of getting two heads, and the second part is find the probability of getting two heads given that at least one head is shown. Now what is the difference between these two? In the first one, you just have to find probability of two heads. So if you look at the sample space, this is the sample space. So two heads come once in four outcomes. So probability of getting two heads will simply be 1 upon 4. So probability of two heads is 1 upon 4. In part B it says two heads given that at least one head is shown. So we have already been given some information. So we need to update our sample space according to that. So if you look at this H, T, T, H and T, T, in how many of these you have at least one head visible? So 1, 2, 3. 2 T's, 2 tails. That is not required now because the information has been given that at least one head is shown. So your investigation will be limited to only these three outcomes, right? So this is how we have updated the sample space. Since we have updated under a condition, so this is a question of conditional probability. So what will be the probability of getting two heads given that at least one head is shown? So two heads Out of these 3 happens once, so this will be 1 upon 3, right? So that's how we work on conditional probability. There are different scenarios and we approach questions on conditional probabilities differently. But the best way to do is with the help of a tree diagram. So have a look at another example. A girl walks to school every day. If it is not raining, the probability that she is late is 0.03. If it is raining, the probability that she is late is 0.08. The probability that it rains on a particular day is 0.30. On one particular day, the girl is late. Find the probability that it was raining on that day. Now, when you are given some statement, some information like this, on one particular day, the girl is late. So this event has already happened. It has already occurred. So now when you're finding probability that it was raining on that day, so it is an example of conditional probability. So let's start with a tree diagram. That's the tree diagram. If it rains 30%, not rain for 70%, late on a rainy day is 0.08, and not late is 92%, and when it is there is no rain, 3% and 97%, right? So first we find the probability which is given, that is on a particular day the girl is late. If the girl is late, what is the probability? If it is raining and she is late, or not raining but still she is late. So probability of being late is probability of rain and late or no rain and late. So when you work out these probabilities, 30% times 0.08, 0.7 times 0.03, and this is 0.045. So this is the total probability of being late. Also, this is called total probability theorem. So total probability theorem is if an event may happen in different possible ways, then the probability of occurrence of that event will be sum of probabilities of all possible ways. So you don't need to base this total probability theorem at this point, but just for your information. So probability of being late is 0.05. Now you have to find the probability that it was raining on that day. So how do we find this probability? So basically we are finding probability that it rained and then she is late. She is late and rained. So this becomes probability of rain and late divided by probability of late. Probability of being late is 0.3, 0.8. This one we found in this part. So now out here, this part shows that it was raining. This shows it is not raining. So what happens to this part? This part will move up as your favorable outcomes. So when you simplify this, it becomes 8 upon 50, right? So this is an example of conditional probability question when an event is given and you modify your sample space to find related outcomes, probability of related outcomes. Moving further, now when A and B are independent, we know that probability of A and B is probability of A times probability of B. Now if they are dependent, then how do we find? We still use the same formula. But if event A has happened first, then the next event, that is event B, will depend upon A. So we just multiply it with probability of A times probability of B, given that event A has already happened, right? And also, if B has happened first, then it will be multiplied with A, given that B has already happened. Fine? Now, using this formula, if you find probability of B when A has happened, will be A intersection B over PA. So if A has happened, it becomes your total, and if you're finding A slash B, then B will come down. So we can use these two formulae to find the conditional probability, especially when you have questions related to Venn diagram. For example, this question. Let A and B are two events such that probability of A is this, probability of B, given that A has happened, is 0.25. Find the probability of A intersection B. So what is the formula for B? Given that A has happened is A will come down and on top you will have intersection. So this is your formula, just plug in these values. So A intersection B will be B slash A times PA, which is multiplication of these two, which is 0.075, right? So this was an example. Have a look at another example. Event A and B are such that probability of A is this, probability of B is this, and probability of A given that B has happened is 1 upon 4. And part is find the probability that both events A and B occur, that is A intersection B, and find A intersection A given that B prime. So how do we do this? Let's start. So we will start using this. A, B is given. This will be A intersection B divided by probability of B. So when you use this formula, you get A intersection means PB times P of A. B is given, and when you put in these values, 1 upon 4 times 1 upon 3 is 1 upon 12. So A intersection B is 1 upon 12. Now for part B, I suggest we draw a Venn diagram. So A slash B prime will be, B prime will become your sample space, and on top what comes? Intersection of these two. So have a look at this Venn diagram. Let's say this is your universal set A, set B, and we start filling in from here. So this will be 1 by 12. A is given 1 upon 2. This intersection is already 1 upon 12. 1 upon 2 means 6 by 12. So minus 1 by 12 is 5 by 12. B is 1 upon 3. That is 2 by 6. And 4 by 12. Minus 1, so 3 by 12. You may keep it as same denominator as 12. No need to simplify, because later when you simplify, this form will be better. So 5, 6, 7, 8, 9 over 12. So outside will be 3 over 12. Right? Now start. Probability of A intersection B prime. A intersection B prime is 5 upon 12. And B prime is out of B 5 and 3, 8 upon 12. So you get 5 upon 12 over 8 upon 12. So 5 upon 8 is your final answer. So that's how we can solve variety of questions based upon conditional probability. If you found this video useful, please like, subscribe and share, and don't forget to press bell icon so that you are the first person to get the notification. Take very good care till we meet again.